Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And we're going to be talking about uh, coverage areas of a couple of different things. Number one, the state of North Carolina is split up into 8 what we call climate zones. So I thought you might be interested to see how that breaks down. And then also, there are National Weather Service offices all over the country, and each one of them has jurisdiction over a certain amount of territory. And I thought, at least in a couple of cases, it might surprise you to find out what National Weather Service office is actually responsible for you when it comes to forecasting and severe weather and that type of thing. So let's go on ahead, and we're going to start off with the climate thing first here. And I hope this map is somewhat readable. All the counties are labeled except the counties you see with numbers on them. You have to look over to the right, and each one of those numbers refers to a different county. The name of the county was just too long to fit in the size of the county, and that's why they did it that way. But basically, you have 8 zones here, and I'll go on ahead and try to highlight these here. Okay, so up in here, there we go. That's the northern mountain zone. And then this is the southern mountain zone. It's actually the mountains and the foothills. And then this light green right in here is the northern Piedmont. Okay, so that includes areas like Yanceyville, Roxborough, Burlington, Durham, Lewisburg, Warrenton, Henderson, Oxford. Okay, and then the central Piedmont is this slightly darker green area in here, and that includes Pittsboro, Siler City, and Raleigh. And then the southern Piedmont extends from Charlotte eastward over toward Carthage and Southern Pines. Okay, and then you have 3 areas in the coastal plain. So those of you in, let's see, Nashville, Rocky Mount, Roanoke Rapids, Jackson, all the way over toward the Outer Banks around Nags Head. That's the northern coastal plain up in here. And then you have the central coastal plain, which would include Smithfield, Wilson, Goldsboro, Greenville. Okay, so that's this area in here. And then farther south, you have the southern coastal plain, and that includes areas like Irwin, Dunn, Fayetteville, Rayford, Lumberton, all the way down toward Wilmington at the coast. Now, these climatic zones can be set up for different reasons. In general, it can be the general amount that you are above sea level or a certain range above sea level. It can also have to do with the type of soil that you have. A number of different factors go into the classification. But one thing I did want to point out is that whenever we see RDU with all of its shenanigans in the summertime, being way too hot, and I've tried to mention this, that, those numbers are thrown out, okay, when they're bad. They're not used to try to prove something that isn't provable, okay? And so in these different climatic zones, there are a ton of what we call cooperative observing stations. And these are, for the most part, in rural areas. And so all of the data from all of these different zones is looked at, and outliers are thrown out. And so this is how we can objectively evaluate how the climate is changing. There's no shenanigans going on here using RDU as the official thing for that whole zone and then making it look like it's warming up like crazy, okay? That there's a lot of quality control that goes into this, and as a result, we can see what the real trends are without any augmentation, real or otherwise. Okay, so the next thing I wanted to talk about was the National Weather Service responsibilities for the areas that they cover. And so I want to show you a map of this, and there are actually 7 National Weather Service offices that take care of the entire state of North Carolina. Now, when I first got to Raleigh back in 1981, the Raleigh Forecast Office was responsible for the entire state. So they had to forecast all the way from Murphy to Manteo and every place in between. And then when the Weather Service modernized in the late 80s and early 90s, they came up with a much, much more reasonable approach. And so Up in here, this very light green area that you see here, let's see if I can highlight that. Well, I don't know why that's not doing it. Can we try one more time? Huh. Okay. Well, anyways, I'll just talk about it. I don't know if you can see my little cursor here or not. But, anyways, the very light green area is covered by the National Weather Service office up in Wakefield, Virginia. Okay. And then this darker green here to the south is covered by the National Weather Service office in Newport, which is near Morehead City. And then the area in southeastern North Carolina, which includes Lumberton, Elizabethtown, uh, and Wilmington, that is covered by the National Weather Service office in Wilmington, North Carolina. So three different offices cover the eastern part of the state. The Raleigh-Durham office covers all of these counties in red that you see here. So that extends all the way from Roanoke Rapids, westward, Warrenton, Henderson, Oxford, Roxborough, and then as far south as Laurinburg, Rayford, Fayetteville, Clinton, and Goldsboro. So again, those of you in Jackson, up in Northampton County, you're covered by Wakefield, and then Roanoke Rapids, you're covered by the Raleigh office. And then these pink colors up in here in the northwestern corner of North Carolina, those counties, and that includes Boone and Wilkesboro and all the way over to Yanceyville, that's covered by the National Weather Service office in Roanoke. The blue colors out in here, that's covered by the National Weather Service office in Greenville, Spartanburg, South Carolina. And finally, the two yellow counties in the southwest corner are covered by the National Weather Service office in Morristown, Tennessee. Now, you may wonder, well, why, are we making things more complicated than they need to be? Well, there's a method to the madness here. And so I wanted to point this out, is that instead of one office worrying about the entire state, when the National Weather Service Doppler radars were first installed, then the thinking was this, and it made a lot of sense. Let's have each one of those radars be the center of a forecast area, and we'll co-locate the office, the National Weather Service office, either at or near that radar site, and then they can use the radar to look about 140 miles in all directions, and they would then be responsible for that forecast area. So that's how that all came about. So now I want to show you an example here. So here's a map of North Carolina and Southern Virginia, and Wakefield is up in here, okay? And if you go out 143.7 miles, which is the range that the data is reasonably reliable, then you go out here and it gets all the way down to almost Lillington. But you see this little thing in here, I don't know if you can read it or not. It says the beam height is 17,000 feet. So the problem is as the radar beam goes out, it's getting higher because it's tilted up a little bit above horizontal, but the Earth is curving away from it. So the height above ground increases exponentially as you go out. If you're 17,000 feet up, you're missing a lot of stuff underneath that, okay? So now let's go on ahead and take a look at the Raleigh office, and we go out 143.7 miles, and that gets all the way up here into southeast Virginia. Now, you see the beam height's only 13,000 feet. That's because the Weather Service office in Raleigh has their beam tilted slightly closer to the ground. But still, that's way, way, way up. And so if we go to the last slide here, I cut that distance about in half, about 72 miles, and that gets up to about Roanoke Rapids, okay? And that's about where the 72 miles would cut off from Wakefield, Virginia. So you want them to overlap, but you basically want to be able to see the lowest part of the atmosphere. And you can see here the beam height's only 3,900 feet at Roanoke Rapids, which is still up there, but it's certainly not 13 or 17,000 feet. And so these radars are strategically placed so that we get the best coverage with the beam closest to the ground. And so as a result, the forecast area covered by these National Weather Service offices is basically the area covered by the radar. And so the two line up very, very nicely. And it works out really, really well. I think it's a much more efficient system than the way it was back in the old days where each office had to worry about an entire state. Okay, I hope that makes a little bit of sense. That is the bonus weather video for today. The next one will be coming up on Friday. Next daily weather update, of course, coming up tomorrow. Y'all take care, folks, and we'll talk to you soon.